So I want to make a couple of more points about cyclones. This is a very important topic, as I said. These are just some images of the destructions brought, and you can see the ocean is right there. So people are living really, really, really close to the ocean with the, as sea level continues to rise, with some hot spots like the northwestern corner of Bay of Bengal, which is sea level is rising at 3 to 4 times the global average sea level rise, and it's accelerating also much faster than the global sea level rise, which means the sea level is rising everywhere, but it's rising faster and faster. So it's not only rising, but the rate of rise is accelerating, and there are some hot spots. We will see why that could be, right? So the idea of global warming also extends to this concept of how hurricane season or any other impact like rainfall, extreme rainfall, or sea level rise can be impacted by global warming. So 2005 season of Atlantic hurricanes became very historical because it had 27 named storms, out of which 15 became hurricanes. Very, very unusual, and it had some very strong category 4-5 storms like Dennis, Emily, Katrina, Rita, Wilma, which left not only a lot of destruction, but the season never seemed to end, right? So this is something to remember. So everybody said 2005 is a clear indication of the fact that global warming is beginning to fuel the hurricane season to be stronger, more cyclones, more hurricanes, getting stronger, faster, and so on and so forth. And then you had several years of fairly quiet years, and again, 2020 is turning out to be a strong year. We are in August. This season should continue till November, so already there has been a couple of hurricanes landed on various parts of the southeast U.S. corner. So now we have to see what else will happen for the rest of the season. So what is the point of global warming? So global warming does not just increase cyclones every year. What it does is it increases the chances that a hurricane season is going to be stronger and more intense by doing something called loading the dice. So in a natural world where, let's say, humans had no impact, no global warming was happening, you will still have years which have more cyclones or fewer cyclones, let's say 100 per year globally. You will probably have 80 or 120 more making landfall, more getting category 5 or super cyclone, and so on. And so that is chance. That's like throwing a dice. There are various natural factors from the ocean, from the atmosphere, that can change year to year variability. What climate change does is not change necessarily every year, but it just begins to make the probabilities of bad years more frequent. This is called loading the dice, because if you have a fair die, when you throw it, each number may have a same chance of coming up. When you load the dice, you can make certain numbers come up more often. So the key analogy or metaphor to remember is that global warming tends to load the dice on certain things like extreme rainfall, cyclones, stronger cyclones, more cyclones, and so on and so forth. So that's another point I wanted to make. So these are the poster children for damaging hurricanes: Katrina, Rita, Williams, historical hurricane destructions in other regions like Hawaii and 1959 and 1982, which is very unusual. It's just in the reach of the edge of the tropics, so and it's in the middle of the ocean. So for cyclones, typhoons to make it that far is quite unusual. Nonetheless, the other point about cyclones is non-local impact. For example, in 2011, Typhoon Haiyan destroyed Philippines. Okay, what are the non-local impacts? Philippines supplies a lot of products like coconut oil, and other coconut products to the world, a major supplier. So when a cyclone hits a place like Typhoon, the supply chain of whatever is being exported by the Philippines is affected. So you can actually calculate how the global economy is affected by the Typhoon Haiyan destroying Philippines. So there are two questions, right? Typhoon Haiyan at the time was one of the strongest, historically the strongest typhoon to hit that region. Did it get so strong because of global warming? And then how is the global economy and the globally connected supply chains are being affected by either more intense cyclones or more number of cyclones? These are the kind of things we have to worry about. So the questions became interconnected from physics, human activities, the feedbacks, and then impacts on economy, on human lives, infrastructure, etc., etc. So all these questions have to be kept in mind when forecasts are being made, projections of how cyclones will change in the future are being made, where people are going to settle down. Are they all going to continue to keep moving towards the coasts as sea level rises and cyclones intensify faster? What is the consequences? How would we protect ourselves? These are the questions we have to always keep in mind.